So this is Mr. Forster here, and today we're going to talk about single displacement and double displacement reactions. So single displacement, which is the first type we're going to talk about, an example of that would be like a single element that is interacting with a compound. Okay, so for instance here, I am the single element. Okay, so I do not have any thing that's paired up with me. Coach Ruff has something paired up with him. He is a compound, and what he has paired up with him is the Call of Duty Modern Warfare 3 game. So a single displacement is where an element in a compound and a single element switch places. So our single element will switch places with our element in the compound, and that would be Coach Ruff and I. And when we have that, those are our reactants interacting, what's happening at the start of a reaction, and what's happening at the end are called the products. So at the end, our products would be Coach Ruff without a game, without Modern Warfare 3, and I with his game. So he's very generous to give me that game. So now I'm be happy and playing Xbox Live. A double displacement reaction is a little bit different because it involves two compounds. So say here we have Coach Williams in his Modern Warfare 3 game and Coach Ruff in his NCAA Football 2012 game. So say they're kind of worn out with these games. They're not really into them anymore and they want to trade places. All right, a double displacement allows Coach Williams and Coach Ruff to trade games or to trade themselves. And these are our reactants. So Coach Williams and his Modern Warfare 3 plus Coach Ruff and his NCAA football. And we end up as products with Coach Ruff having had NCAA football, now has Modern Warfare 3, and Coach Williams has NCAA football now. So everybody's happy. So let's kind of look at the steps to decide how to attack one of these, because they can be a little overwhelming if you don't follow the steps. So the first thing you want to do is find the charges of the things you start with. Okay, those are the reactants. Okay, often of the time, or pretty much all the time, these are going to be ionic compounds. And most of the time they are going to have a polyatomic ion in them. Okay, so you got to watch out for that. Look on the back of your periodic table for that list of polyatomics. And then you want to write those formulas correctly. Okay, those are only going to be ionic compounds, and I don't want to use prefixes, so do not use the prefixes with this. All right, so remember, to write an ionic compound, I switch basically the charges. Okay, if you're having some trouble with that, ask somebody else in the class, because we have went over it pretty extensively. So now when you write those formulas correctly, then you can switch the positive elements. All right, those elements with the positive charges, you switch them and pair them up with the other thing. All right, and when you do that, then you can rewrite the formulas using the writing ionic formulas method, and then you can have your new compounds. So let's kind of go through those and kind of see what they're talking about. So a single displacement example would be zinc or plus sodium hydroxide. So the first thing you need to do is write out what you have. All right, so zinc would be Zn. Okay, that's pretty easy there. And it would have a charge of 2 plus, but since it's by itself, it doesn't have a charge. Okay, so that's a little thing that's tricky about single displacement. When elements are by themselves, they don't have a charge, but when they're paired up, they do. Okay, it's kind of weird. And sodium, I'd look on the periodic table and find that that's got a symbol of Na, and I'd look that it's in the 1 plus column. And then I'd look also and see that hydroxide, that's not an element, but I know that polyatomics sometimes can end in IDE as well. So I look on the back of my table and find out that that's OH minus 1. Okay, so now I've got all I need to write my reactants out correctly. So I've got zinc plus sodium hydroxide. Now if I write that formula out, remember this one, let me change color here real quick. That one that's paired up with the sodium will switch with the one that's paired up with the hydroxide. So there, let me rewrite that up here. Sodium 1 plus OH minus 1. This one goes down there, that one goes down there. So my compound would be sodium hydroxide, NaOH. All right, so we do what we saw following those steps. We switch the positive ions. which would be zinc 2 plus and Na 1 plus. So there with that. All right, so now Na would be left without modern warfare 3, and I have my other thing, which is zinc hydroxide. And remember, from up here, zinc, I'll write it down here, zinc 2 plus and OH 1 minus. I have to write that correctly. So my 2 would go down there, my 1 would go down here, that would be zinc. And then since I have 2 of the hydroxides, this 2 right here went down with the hydroxide, I would have to put parentheses around my OH and put a 2 outside of it. Okay, so that's my complete compound there, or my complete formula for my equation. All right, zinc plus sodium hydroxide gives me sodium and zinc hydroxide. All right, so that's the single displacement. We're going to talk about those probably tomorrow. And then today we're going to talk more about double displacements. So double displacements, this is number 2 on your worksheet. Double displacement are a little easier, I think, because there's not a whole lot of thinking that's beyond the few basic steps involved. So I just want to write the symbols for what I have. So I have silver, which is Ag. I have nitrate, which is NO3. I have potassium, which is K. And I have phosphate, which is PO4. All right, so I want to figure out now what the charges for those are. So now I'll write the charges. Silver is a transition metal, but it's always going to be 1 plus. That's on the back of your periodic table. Nitrates are also on the back. It's -1. K is in the first column, so it's +1. And then phosphate is -3 because it's a polyatomic. It's on the back of your table. All right, now, so I want to write these correctly down here. So my first thing would be silver. Remember, I switch these charges, one down there, one down there. Since they're both 1, they'll really just cancel each other out, and I just have AgNO3. All right, pretty simple if they're both the same number. They cancel out. Okay, over here, they're both not the same number. So this 1 will go down here with the phosphate, and that 3 will go over here with the potassium. So now I'll have K3PO4. Notice there that I did not move the 4. All right, if it's something that's already down below the letter, it's going to stay down below the letter. The only things I ever move down or switch are the things that are up top. Okay, the charges. Those are the only things I switch. All right, so now I'm ready to rewrite my compound. I've got my reactants. These are reactants over here. And now I want to figure out what my products are. The products. Okay, so I know that my positive ions are going to switch places. My potassium, my silver. So those are going to switch there. And when I rewrite that correctly, I'm going to have potassium with NO3. So I'll have, let me see here. Got color than that. Color blue. Oh, so I'll have potassium, which is K1 plus, and NO3, which is 1 minus. So if I write that correctly, that'd be KNO3 plus. The other thing I'll have is silver phosphate. So Ag is 1 plus, phosphate is PO4, 3 minus. So I'll have Ag3PO4. All right, so those are 2 kind of examples of single and double displacement. If you need some more help what's going on here, rewatch this, okay, pause it, look at what I'm saying, and then if you're still having some questions, ask somebody around you because they can probably put it a better way than I could for you to understand because they speak your language, which is teenager. All right, so that's it, and good luck with single and double displacements.